The network is no longer just a pipe, it is a critical infrastructure that connects the AI thought process to the end user.
Welcome to Beyond the Fiber, our first episode. This is a show where we break down technologies and discuss what it really takes to build next-generation service provider AI-ready networks. I'm your host, Robin Olds, and in each episode, I sit down with the people building the networks, shaping the future of the industry, and sharing insights that you can use. That includes what's working, what's not, and why it matters. Now let's get into it. Today's episode is on xHaul, and my guest is Waris Sagheer, Senior Director of Product Management, Data Center, and Provider Connectivity Group at Cisco. Waris, welcome to Beyond the Fiber.
Thanks for having me, Robin. It's a pleasure to be here.
Well, thank you for coming. So, Waris, tell us a little bit about your role here at Cisco.
Yeah, so I lead the product management team for Cisco's Provider Connectivity Group, where we define the architecture and solutions that empower the world's most critical service provider networks. Right now, our focus is the evolution of 5G Advanced, 6G, and AI-driven networking, ensuring that transport structure can handle shifts in traffic patterns and the low latency requirements of LLM era, or we call it large language models era.
And of course, large language models is around AI and what feeds that. Jumping into a little bit deeper conversation here, we have various types of listeners out here. Waris, can you explain what xHaul is and why it is considered a strategic growth area?
Certainly, just to give a context how mobile networks are built and for people to understand how your phone connects with the mobile network and how the entire plumbing happens. So when you use your phone to find directions on Google Maps or make a video call over 5G when you're not at home, your device first connects to the radio, which you may see outside when you are driving. You see these towers and these antennas out there. That's called radio access network in a mobile network. That radio access network is connected through a packet transport network, meaning bunch of routers and switches, to the mobile core. That mobile core is kind of a brain which processes this request and reroutes the traffic to the internet. Packet transport network in the middle, comprised of which we call it fronthaul, midhaul, and backhaul. I will explain these later. But collectively, we call them xHaul. It is the indispensable glue connecting the mobile core to the RAN. So in the 4G era, and as you know, 3GPP, which is the mobile kind of standards body, so they set these naming of 2G, 3G, third generation, fourth generation, fifth generation. In the fourth generation, previous to fifth generation 5G, the transport was simple. It was appliance-based, meaning these were not compute, these were just appliance sitting there. So that basically made the backhaul pipe. That transport used to be called backhaul. When 5G came in, technologies evolved. So it was no more appliances. We call it decomposition and virtualization of network function. Basically, now you can run those functions, network functions like RAN functions or mobile core on a compute. So the mobile core split into two components, which we call it as centralized control, meaning like control plane and user plane. And that's basically UPF. The baseband unit, which is part of the RAN, also decomposed into two components called CU, centralized unit, and distributed unit. By the way, it can be a vRAN and Open RAN. We'll talk about later. But to be precise, somebody needs a definition. Backhaul in this new world of 5G is between UPF and CU, centralized unit. Midhaul is the interface between CU, centralized unit, and distributed units as part of the RAN. Fronthaul is basically the high bandwidth, low latency connection from distributed unit to the radio. Mobile networks operators utilize a strategic mix of their own network, and they also use wholesale xHaul providers or like backhaul providers to connect to their cell sites. So you asked about the strategic also. So xHaul is extremely strategic because the dumb pipe business model is dead. So as we move from 5G to 5G Advanced to 6G, the transport layer cannot be a passive observer. It must be an active, programmable participant in the service chain.
Okay. So what does that mean for Cisco and our service providers?
Yeah, for Cisco, xHaul is the critical junction where our Silicon One performance meets SRv6 intelligence, allowing us to program a deterministic and policy-aware path from the cell side directly to AI edge platform. And this will help telcos to evolve from just providing the voice video data services to delivering AI services.
And just one note on Silicon One for those that don't know, Silicon One is our strategy around silicon, and we're building our own so that we can make it programmable. We obviously have different types of Silicon One chipsets that some are used for data center and other areas, but some are used in the Cisco 8K platforms as an example. But it's how we deliver this technology. Whereas why now, and what are the key industry trends and drivers that make addressing XL so critical?
Great question, Robin. And I would like to share some statistics from the 5G world. So it will give you an idea where we are from 5G and 5G Advanced and why XOL is critical. So as of late 2025, GSA is Global Supply Association. They publish these reports. And according to their November 2025 report, 384 operators globally have launched 5G in the world. However, out of 384, only 95 have deployed standalone mobile core. Remember, I talked about the RAN and the mobile core? That mobile core is basically in a 5G world can be deployed in two ways, which we call as non-standalone or standalone. Non-standalone is actually you use the old 4G core, but you deliver 5G services. Standalone means purely 5G core. And why we need 5G core? Because without standalone, you cannot do voice over NR, network slicing, or 5G advanced features like NTN. So it's critical for operators to move to 5G advanced. Now, fixed wireless access is one of the biggest use case for G as of today. So 175 operators globally are now offering fixed wireless access services. And there's an interesting trend we are seeing in the industry from mobile network traffic perspective. We're also seeing surge in uplink demand that requires special radio planning. And you may ask why? Very simply, social media, video meetings, all these are drivers of more uplink traffic. To compare to traditional world, we used to basically have a large amount of downlink traffic, which is the internet traffic used to be, and very small amount of uplink traffic. So this shift is already happening. And I will mention to you that why it is important from AI perspective later. So you asked about the strategic urgency for XFAL today. So there are four industry trends I would like to talk about. One is the visibility cliff. So three protocols: quick, encrypted client hello, and DOA, DNS over HTTPS, basically have effectively created a silent network. So let me tell you what that means. Our traditional internet traffic has been on TCP, by the way, and we were using encryption, but not at that level. So when you're using internet, the service provider can see, it can read, okay, you are going to netflix.com. So they can have this, they can study, they can look at that. But once you encrypt everything, you cannot see anything. Once you cannot see anything, you don't know what is coming and what is going. So by encrypting these, headers, deep packet inspection cannot happen pretty much, right? So now the challenge is we are in a black box era where 70% of traffic is video and AI traffic is growing also. So interestingly, AI traffic is also predominantly, it is TCP also, but it is quick too. So it will have the similar problem. So now without the knowledge of what kind of traffic is, your SPs cannot differentiate between a large video file versus a mission critical AI request. Hence, you need to have that intelligence. And that's something I'll talk about how machine learning can help here. So that's basically one. Secondly, the trend in the industry is now we are moving from 5G to 5G advanced and 6G. So 3GPP goes by release numbers. They have release 18, which is 5G advanced, is now active, commercially rolling out. The key feature in 5G advanced is basically reduced cap. Reduced cap means reduced capability like IoT devices and other. Second, the main one is non-terrestrial, which is satellite. When I use the word satellite, I'm talking about LEO, low Earth orbit satellite, like Starlink you would have heard about, or MEO satellite, medium orbit, or geo satellite. So these have been there for a long time. So we are integrating like LEO, MEO, geo satellites into our backhaul and using geo for high availability and LEO for low latency and bandwidth. Now, looking forward, G is also on the horizon. We are talking about, release 22 or something. Cisco is proposing in this to make things simple. We are also asking to replace, we have put a proposal, it requires significant work with SRv6 to native simplified user plane and QS mechanism. Basically, it will greatly simplify the mobile network architecture. Third one is AI for RAN and AI RAN. So that's an interesting, I know it seems pretty close, but there are very significant difference. When I use the word AI for RAN, What I'm talking about is using AI and ML to optimize existing operations, such as interference mitigation in a RAN network, meaning if something happens there and you don't get a good coverage or good signal, or energy efficiency. And those things, basically, when you are using AI to do this, that's called AI for RAN. Second is SRAN or AI RAN. It's a precursor to 5G. So where AI and RAN workloads share the same hardware. So like, for example, we have Cisco and NVIDIA partnership, which allows UPF and AI inference application to run side by side, right? So we share the same hardware. It makes things simple. You can place them on edge. So XOL will play a crucial role in connecting AI workloads. That's basically the third one. Fourth one is agentic AI. We have moved from Gen AI to agentic AI. You hear everything now. Everyone talks about agents. Agents are pretty much, if you think about it, they are a digital employee. These are your brainstorming partners, right? So they can do your task now. Now there are tools, OpenClaw and everything. You can do whatever different tasks with it. But these agents generate uplink heavy, latency sensitive traffic. And in general, AI requires new KPIs. So we cannot just measure the networks using network KPIs anymore, like, latency throughput. We are now need to measure time to first token and token latency. By the way, you may ask what is token? So what is token? Token has a very important significance. Token is the smallest unit of data that your large language model reads and produces. So timing of token actually contributes to user experience. When you are using ChatGPT or Gemini or whatever tool, you type your prompt, you receive it. If it is slow, you feel that it's slow. If it's fast, it's your token timing there. But in this case, what the critical part is, your traffic goes from your compute to the network to the compute and then comes back. So there is a correlation between the network and the compute. Hence, if the XHAul doesn't provide a predictable path for these tokens, your AI user experience will stutter and fail. Bottom line is, XHAul is not just the glue, it is the critical AI infrastructure.
For a second there, I heard token. For those of you listening out there, and I was thinking of token ring. I was hoping we're not bringing that back. You mentioned a major shift from Gen AI to agentic AI, which is moving from passive user prompted content creation to proactive autonomous agents that stop talking and start doing. Cisco is predicting this will cause a major spike in network traffic, moving from infrequent high bandwidth spikes. Think of up, down when somebody does something from a Gen AI perspective, but when you go to agentic, now that becomes more of a consistent high baseline of traffic as the agents continually interact with each other and data sources. I think that's some of the
Very true.
concern, right? Sorry, go ahead, Waris.
I think that's very true.
So, what architectural and technology factors are shaping the future of XHAul networks?
Yeah, so as we move toward from 5G advanced to 6G, we are seeing a fundamental shift from monolithic architectures to what I now call it as unified services AI fabric for mobile operators, or we call it communication service provider. So this unified services AI fabric, the XHAul, which I can call it the new XHAul, is the foundation for the LLM era or the AI era, where the network is no longer a passive pipe, but an active participant in the AI's thought process. 5 critical factors are shaping this future that telcos become AI interconnect providers. And I use the word AI interconnect provider basically from a user. If somebody needs to access Gemini or ChatGPT or Claude, or their traffic needs to go through a mobile operator. So there's a big shift which is happening. Is one is shift to distributed AI edge architecture. We are moving away from monolithic core to distributed edge fabric. I will elaborate on this point also later when I talk about the actual implementation. Universal connectivity. So that's a very interesting word, by the way, is terrestrial network and non-terrestrial network integration. What that means is today you are using a cell phone through cell towers. Tomorrow, your cell phone can also talk through satellites. So you are in an area where coverage is there. You talk to your cellular tower. You move to let's say, trail where there's no cell tower. You will still be connected through satellite. So that integration is very, very interesting. And if you ask me, Robin, this is one of my passion, and this is one of our drive from our team, is that we want everyone to be connected anywhere, regardless of where they are. They are in, a mountain or a city or wherever, they should be connected. So this is true LLM fabric, where The access is terrestrial, non-terrestrial via LEO, MEO, or GEO satellite. This ensures quality of experience across terrestrial and satellite links. Third one is AI network slicing. So we are moving beyond bandwidth management into dynamic AI-driven network slicing. So this ensures latency-sensitive, monetizable inference workloads are isolated from standard traffic. This helps from monetization for mobile operators. And then LLM performance matrix. I spoke about tokens. I spoke about why it is critical not to just rely on network KPIs. Traditional network KPIs, latency, jitter, and throughputs are mirrored by LLM-specific metrics like request latency. Request latency is basically from you type the prompt, you get the entire response, time to first token, or token latency, which is kind of a jitter. To ensure AI performance is predictable, we correlate LLM metrics with network performance measurements. I will also touch base upon a couple of other trends that you asked about which is critical now. So next gen hardware, when I use our hardware, I'm talking about routing platforms. So modern routers now require flexible support from 800 gig to 400 gig to 1 gig interfaces with high port density. And we would like them in a fixed form factor. It's very interesting, by the way. When I started my journey, started my journey in the core routing business in Cisco. This is back in 2001. 10 gig at that time was a big thing. A single interface can have 1.6 terabit per second. This is fascinating. So that's basically and then you need flexibility also. Clocking and sync is a very important part in a mobile network. It is like the most important part, I would call it. So adopting network-based timing and dual band PRTCB, basically GNSS receiver. This is basically the GPS and GNSS we are talking about to eliminate reliance on vulnerability of distributed GNS. But keep in mind, the current systems are very prone to jamming. Lastly, I would call it network resiliency. So using LEO, MEO, GEO satellites or free space optics to provide mission critical or backup or disaster recovery, all those use cases are there.
Yeah, you made an interesting point about when you're off the trail. I was in Joshua Tree recently and my phone lost service, but Starlink picked it right up and said I had cellular service. Not cellular, but it had the capabilities to communicate if I needed to, which I thought that was really cool that it could do that. So, I guess that brings up how does XHAL support the evolution of the mobile network from 5G to 5G Advanced and even 6G, as you mentioned earlier?
Yeah, and this is something we have been talking about the whole LLM era. So telcos have if you've done a great job, if you see the move from circuit switch voice to data and then video. If you see the era from 90s to 2000, and in fact, people do not realize, prior to 2000 and prior to, when the iPhone and smartphones came into the picture, video was not a thing. And then video became dominant. So telcos moved from voice to data to video. And now we are in this LLM era. So 3G, 4G was the best effort data. And then 4G did a great job, by the way, and it still is. 5G brought this concept of enhanced mobile broadband, massive IoT, and ultra reliable low latency. We still need to find the use cases for that, some of them. But 5G fixed wireless access. So 5G advanced NTN and 6G will require integration of AI RAN that I spoke about and non-terrestrial network, which will be an integral part of it. So as we move towards 5G advanced and 6G, there's a fundamental shift I talked about, and I spoke about the unified services fabric. So consider that XHAL now unified services fabric. The key component of that unified services fabric is the underlay. And that is basically at the foundation of this fabric will be SRv6, which will be offering simplicity, programmability, and scalability. So for the audience to understand very simply, when I'm saying SRv6, basically the best of IP and the best of MPLS together. And this makes it so fascinating because now you can connect the on-prem to private cloud to public cloud seamlessly. And I have built networks for a long time, and it's a very complex task when you're bringing two MPLSs domain together and do all of those things with different kind of technologies. But you have IP, it just makes things very, very simple. And SRv6 extends IPv6 by adding best of, we have heard about the MPLS or SR MPLS world even, traffic engineering, fast reroute, VPN, service chaining, all using the IP framework. So that is a pretty cool stuff. But on top of that, which segment routing did is also added advanced observability measurements and integration with cloud, AI, SD-WAN, and automation platform. You can measure the using TWAM, the link latencies, and all the other stuff. So in addition to, I spoke about KPI measurement that you can do now in the network. So that will be part of Unified, that you can also measure the LLM performance matrix. And BGP VPN will continue to provide multi-domain connectivity, and the architecture will be distributed. I spoke about how the shift in distribution is happening, right? So network functions will be decomposed, meaning broken down and virtualized. Data plane moves closer to the edge, supporting horizontal scaling through an edge fabric. So remember, in a mobile network, in a prior world, in a 4G world, every request from your phone needs to go to the mobile core. It has to. Then mobile core opens the packet and say, hey, what do you want? Where do you want to go? And that decision used to go to the centralized places. Now, with the decomposition, that mobile core can come closer to the user. If it comes closer to the user, I can do distributed peering. I don't need to go to the internet again to the central location. So what I do is a fan out. So that makes your network not to carry or have a burden of continuous capacity planning. These are the huge benefits of network simplification. The control plane can be centralized. It can be on-prem, it can be on cloud. And now with this new distributed network, or call it metro networks, we call it, it is not just internet peering. Now you will be connecting directly to AI service provider, just the way we have been doing with the content providers. And we will have interconnect with public clouds and also emerging neo clouds. The neo clouds are the new, sovereign, and they provide they are GPU rich. That's something to be. And with this foundation, service providers can begin delivering secure AI interconnect services to enterprises using AI network slicing to ensure performance and resiliency. This also allows them to host AI edge platforms. When I use the word AI edge platform, these platforms can have small language models, large language models, inference side by side with a user plane function. Why it is important? Because it will drastically reduce the round trip for agentic AI interaction. You talked about the agentic AI just now. And so to reduce that latency, they're sitting side by side. Now, once you have that AI edge platforms, you can also host SLMs and LLMs and domain-specific AI models, right, for inference to support SP's own operations, or they can offer new services like GPU as a service. This enables monetization. In fact, I would say partnering with NeoCloud from SP's perspective can be a great way to launch these offerings while ensuring resiliency, compliance, and cost optimization through applications like LLM routing. So all of this will be operated through autonomous operations and assurance. So where AI agents continuously monitor, optimize, secure the network end to end, and through machine learning, network intelligence, that we do traffic optimization.
Yeah, it's interesting. Something you said in there, if any listeners out there have attended any of our previous shows last year, we talked heavily about the Cisco Agile Services Networking architecture, right? And this is really, really important to take away from is moving that architecture to whereas mentioned how the peering is now at the metro edge versus you still have it in the core, but now you're distributing across and reducing that latency down. I think that's a really great point, the way you tied that in there. And also I have a question for you, whereas kind of off topic, but you mentioned it a couple times. Definitely want to know what router was around back in you said, or to early 2000, or was it, I'm thinking the CRS1, but maybe not.
It was before CRS1. That was GSR. That was gigabit switching router.
Okay.
The CRS came afterwards. And by the way, believe it or not, GSRs are still in their network in tier one operators. So they used to call it 12,000 series router at that time.
If anybody has one out there, your account team is waiting for you to call them right now. So we got lines open. But so let's go. Next question. How does Cisco xHaul solution integrate with emerging technologies like AI for RAN, AI RAN, and then Open RAN, and then NTN, non-terrestrial networks?
Honestly, Robin, we don't treat these as separate silos. They are integrated components of the unified services AI fabric. So our architecture is built to ensure whether the service is delivered through terrestrial, cellular, or fiber, or non-terrestrial, via LEO satellites or GEO or MEO. The security, reliability, and assurance are identical. Now, in terms of you asked about AI RAN and AI for RAN. So as I mentioned, now since Unified Services AI Fabric is AI aware. So it does take care of that part. For Open RAN, we have been deploying Open RAN, and in fact we deployed one of the biggest Open RAN deployment in the world from Cisco side. And we have the devices like we provide density, low latency switching for ODU to OCU and the ORU to ODU fronthaul interfaces. So we have done significant work on Open RAN side. We have actual deployments globally, and we have proven to the world, which is the beauty of this, that packet networks, which basically is a big evolution of 5G, is moving the RAN networks from CPRIs to packet easily. And that basically makes the network consistent end to end, and you can have a very seamless experience. So from Cisco's solution offering, I would say that we are offering unified Silicon One, a strategy that you touch base upon, our silicon strategy, meaning the chip which goes into the router and operations. So Cisco 8000 and NCS platforms provide the deterministic fabric. From software and automation, we have integrated agentic ops into our crosswalk network controller and assurance stack. Also, we are bringing the new functionality in it for machine learning intelligence to see through the visibility cliff. Remember, I talked about the quick and now you can, using that feature network intelligence, you can have a view what kind of traffic is going, and that can help you to optimize the network for both energy efficiency as well as an user experience in real time. So we have that capability. So we actually run machine learning algorithms in our routers in those cases, and they basically provide, or we can run this upon a compute also. So we have both offerings, and that's something we are also using, just to let you know, for AI traffic studies. So we are working with telcos, and we have basically monitoring their entire network for about a year now. But that provides a very deep intelligence of what kind of AI traffic is. From security perspective, our hardware platforms, we have chips from hardware security perspective, and then software security we are there, and we have also enabled features from protection from DDoS attacks, and even we have mechanisms now to protect against quantum-based attacks. Right. Bottom line is we aren't just selling boxes; we are selling solutions. We are selling autonomous assured network.
Can you describe the role of segment routing, SRv6, and network slicing in an xHaul architecture? You kind of mentioned it earlier on, but I think let's dive a little bit deeper into that.
I'm glad that you asked it, because I think this is one area where I think it requires some clarification. Unfortunately, slicing didn't pick up the way in a 5G world as we wanted. Still, it is, I'm not saying it is not, it is still work in progress, right? So let me tell you that first thing from, since you asked SRv6, so SRv6 is the programmable foundation of the unified services AI fabric I mentioned before. Network slicing is how we monetize that foundation. And I will connect the dots. So first, let's define network slicing. So it is fundamentally end-to-end partitioning of network resources and functions so that mission-critical applications like a distributed AI workload can run in total isolation with guaranteed business-level SLA. So for customers, slicing is about moving beyond best effort to guaranteed outcome. And we define SLA as sum of two parts. First is SLO, service level objective. These are measurable metrics: jitter, delay, loss, availability. Then there is SLEs, service level expectations, which is a business logic, such as disjoint paths or for redundancy. These are the things you cannot measure. Country sovereignty, regional avoidance. So to deliver these, and as I said, SLA is a combination of both. To deliver these slices at scale, we use SRv6. We use FlexAlgo. We create multiple virtual topologies, one for low latency slice, one for high bandwidth slice over the same physical network. However, managing these thousands of slices is impossible manually. So we use our crosswalk network controller as our SDN orchestrator. So in a slicing world, there are three components in a 5G slice. Mobile core, in the three domains I would call it. This mobile core, packet transport, and the RAN. Remember, I talked about these in the beginning. What we are talking about is the transport part of it. So in slicing world, they use these terminologies, which they call it as NSMF, network slicing management function. Consider something at the top sitting like a master controller. And then each domains have their own controller, which is called as network slicing subnet management function, NSSMF. So mobile core has its own NSSMF, transport will have its own NSSMF, and RAN will also have its own. All these three of them will talk to the master. So I am talking about the transport NSSMF, which is our transport network controller. And it automates the four legs of every transport slice. Path forwarding, your SRv6 flexible, QoS, BGP-based services, and assurance. Now, the most exciting evolution, which is, I think I find it very fascinating in 2026 is AI network slicing. Now you can slice the network to carry AI traffic for your enterprises and provide them guaranteed SLAs. We can now create, in fact, a wall garden for enterprise AI traffic that and we can include embedded LLM routers. So what exactly is a LLM router? It's not just an app, it's a network function. A TMF forum is also talking about this right now, that monitors the network in real time to route AI requests to the best available inference node. It optimizes both tokens and cost. So the critical takeaway is that while 5G drove the need for slicing, it is equally applicable to wireline network also, by the way. So you can do slicing in a wireless network, you can do slicing in a wireline network. So today, any service defined by a business intent can be delivered as an automated assured slice.
It's interesting. Service providers, if you haven't heard this, this is really important. I really want to harp on this for a second. Network slicing. So I've talked to many of you, some of you I haven't talked to, but many of you I've talked to are saying, hey, how do we monetize AI traffic across our network? Whereas is mentioning how you do that, being able to offer an SLA broken down into two different categories, but it's something that Cisco can provide you. So I really want to point that out. And then whereas I heard you might be going to Mobile World Congress?
And interestingly, we have this demo where we will be showing, and I can tell you the demo name. And for folks who are there, I would highly encourage them to visit the booth, Cisco booth, I would say. And the name of the demo is Monetizing SP Infrastructure with AI Traffic Network Slicing and LLM Aware Routing. So exactly what I talked about, will be showing there. It's a very interesting demo where we will show how you basically can route the AI request to even, to public LLMs, and in case of privacy to local LLMs, and how you can host your own AI edge platforms and route the traffic, and how you prioritize them. So this is something very fascinating. And I think I would say that please visit the booth and see the demo there.
The next question is what really differentiates this solution over others that are out there?
Yeah. So before I talk about the differentiation, Robin, I would say we have to look holistically this whole solution. We cannot just look at one routing and one software. So it's more than that. And what we are trying to do is we are trying to bring silicon optics routing compute into a unified architecture. And that makes the solution powerful. We spoke about Silicon One, so I can elaborate a little bit on that. That ASIC or the chip, which is in your routing platform and which is part of a strategy, is a game changer for us because it provides a unified architecture. It provides high capacity and scale, service conversions, optimal network design. It has fully shared packet buffer, flexible interfaces, traffic management, load balancing, and comprehensive security. And then it also provides visibility and analytics. So it is an scalable and offers programmable solution for our core aggregation edge and access networks, which is part of your mobile network or communication service provider network. It also allows for fixed platform that save massive rack space and power critical for meeting ESG goals. It offers, 1 gig to 800 gig. Remember, I talked about the flexibility required with high port density, reducing the total cost of ownership for SPs. And from actual platform perspective, we are offering Class C timing with GNSS with PRTCB for better performance and resiliency. SmartFan algorithms we have introduced, which offer better power efficiency, 40% lower power, exec like MEC security and IPsec up to 200 gig on our access platforms. We talked about Green Silicon One, and then even the PSUs, they are 80 plus certified. Another important part of our solution is routed optical networking, which is driving massive power and cost saving and is a critical part of communication service provider infrastructure. We spoke a lot about SRv6, which provides differentiation, traffic engineering, and programmability. So that's your underlay, and BGP VPN as your overlay. And I know, Robin, you touched upon Agile Services Network. So Cisco brings this proven blueprint for AI network, which is called Agile Services Networking. And we take all of these together, put them in a solution, and validate it and test it and publish it. So it builds on 4 pillars: AI infrastructure or AI operations powered by agentic AI, security, and also how can you offer new services. And one of the key components of this solution is our crosswalk automation and assurance, obviously, because you do all of them, and you need something AI enabled, multi-vendor of the complete life cycle of network operations. It offers planning, orchestration, optimization, workflow, visualization, automated assurance. And now, as I mentioned before, we are introducing a new component to this, our assurance solution called PCA-UE, which is provider connectivity assurance user experience. Some big names. It provides three major applications: network intelligence, network optimization, and energy efficiency.
And for provider connectivity assurance, for those also listening out there, that's the formerly acquired Obsidian Skylight. So that's what or is it referring to as PCA? So again, tell us some of the common challenges customers, service providers are facing in deploying xHaul networks, and how does Cisco address them?
There are multiple. I'll just focus on a few to give you the challenge. One of the biggest challenges is operational silo within communication service providers, or SPs, I would call it. So basically across WAN, packet transport, and mobile core. So what we are trying to do overcome this is multiple ways. One is this solution I talked about, PCA UE, is actually a pretty cool tool to do that work. So today, the transport people, by looking at the IP flows and using this PCA UE, they can get a very deep understanding of the RAN network. They can exactly see, okay, which cell site is congested. Not only that, they can also see a user experience like you and me. They won't see the username because that's for privacy reason, but they will know exactly that, hey, what Waris has is Waris having a good experience. Okay, I'll do a time travel. Waris was having a good experience, then he has a bad experience. So is it a cell issue or it's a device issue? It's a location issue. That kind of information, everything we are talking about is we are extracting from IP flow. We are not asking the RAN person. We are not asking a mobile person to do this. That kind of information helps to build a better xHaul. Apart from that, agentic AI for inter and intra-domain troubleshooting. When I use an inter meaning from packet transport and across to mobile core and RAN also. So and this is a project Cisco Foresight you may have heard about, and we are basically bringing multiple functionalities in a configuration drift, toxic factor. There are many applications will be coming there, but the main goal is to basically give you the ease of troubleshooting, which used to require multiple things to be done. Another challenge is blocking and sync. As I talked about this before, we have been asking industry to move towards network-based timing and to reduce reliance on GNSS and GPS. So traditionally, what they do is they put on multiple cell sites. What we are asking them is to a network-based timing so that it becomes more centralized and distribute the timing to the cell sites. And this will help and using dual PRTCB GNS receiver, basically it will help to improve accuracy as well as resiliency. And lastly, one of the biggest challenge is resiliency in the network, and especially disaster recovery, floods and others, and the natural disasters happen all the time. So in that case, satellites and other technologies can be a great solution for backup technologies in case of any failure so that the user experience remains consistent.
Okay. So, we're kind of in the home stretch here. We have a few more questions. How does Cisco envision the role of xHaul enabling new services and business models for service providers?
Robin, this is something I am very passionate about because I think that SPs sit at the intersection of demand and intelligence. So here are a couple of things, right? They already have the fiber, metro sites, meaning reach, and trusted operations to host AI workloads. So ultimately, this unified services AI fabric or the new xHaul enables secure AI interconnect, helps you to connect to public LLMs, edge hosting, even position SPs as potential AI exchanges, facilitating compute, model, and data exchanges between ecosystems. So by extending these assets into AI edge platforms, SPs can enable inference hosting, GPU as a service, data sovereign as a service, closer to users. That's a real differentiator versus hyperscalers. Modernization opportunities, I see multiple. I spoke about AI network slicing. This is something I think it is definitely out there. They can also do something new like LLM routing and orchestration, meaning providing resilient, policy-aware routing and orchestration across distributed inference endpoints, edge regional cloud, with built-in guardrails for governance, compliance, and safety. GPU as a service, offer GPU, TPU, and NPU clusters, or inference as a service, host LLMs, SLMs, and at SP Edge or regional data centers. And I would also say, how about data as a service? Because SPs have so much data, so they can monetize network user IT telemetry data. Obviously, you have to make sure the regulatory compliance and everything, but that's a pretty interesting area. And lastly, I would call it open gateways, the global system for mobile communication, for which this has this open gateway APIs like identity, QoS, and location. They can monetize that also. Yeah. So overall, those are the areas where I think they can certainly monetize.
Are there any innovations that you can share with everybody here that we'll be working on in Exol?
So my team actually, one of the job of my team is to do work with innovation or within our Cisco partners, and as well as collaborate with external community. And we do a lot of incubation projects. So I cannot talk about the specifics because these are incubation, but I can give you a high level area where we are focusing a lot right now. And you may see something in coming years if they actually we build that. So like we are looking into embedding AI into our platforms, and we are also investigating quantum key distribution over satellite networks. We are investigating some, other areas for network resiliency, which will make, up to short distances, very high speed data with something which will really help in disaster recovery and other things. And then obviously autonomous operation is basically is the way to go, and how networks will operate.
Waris, as we close here, if you could leave listeners with one message, what would it be?
Yeah, if I could leave with one message is this XHAL will play a critical role in connecting AI workloads in the LLM era. The network is no longer just a pipe. It is a critical infrastructure that connects the AI's thought process to the end user. So that's why I was using the word unified services AI fabric. As we transition into the agentic AI, we need a unified services AI fabric that is deterministic, automated, and secure against future threats, including quantum safe networking. Without a scalable XOL foundation, the promise of distributed intelligence simply cannot be realized. And I would close on that at Cisco, we aren't just building for connectivity, we are building the nervous system for AI driven economy.
All right. Well, thank you, Juarez, for the conversation and overview of Exalt today. This has been Beyond the Fiber. To hear more about where the industry is going and how we get there, join us March 25th as we have a special guest, and it's going to be at 1 p.m. Eastern, 10 a.m. Pacific. I'll be speaking with Lumen Technologies' very own Francis Ferguson, distinguished engineer and chief architect. With that, I'm Robin Olds. Until next time, keep building.